Hello again, our most valued student. My name is Confident and welcome to Tech College. This lesson is a revision of the Mathematics N3 question paper that was written in August 2017. And the purpose of this lesson is to provide you with some of the suggested solutions. Should you require more of these lessons, you can email us on info@egorlentechcollege.co.za. Or if you need more of these question papers and answers, not only maths but also other subjects, you can send us an email to www.egorlentech.co.za, or alternatively, you can call us on 011 040 7343. As I said, this is the Mathematics N3. We have a full curriculum of the Mathematics N3 whereby you can use it to prepare for your final exam. We also have some of the answers that we provided for different question papers in the years. Now, should you pick up some errors in this memorandum, please note that the errors are not the responsibility of the Department of Higher Education. However, of the persons who made them. In this case, it is me. Now, should there be any errors that you pick up, you can also suggest some solutions and we'll be able to make the necessary changes. Also, please note that no part of this video may be reproduced in any form, be it by print or photo, print or duplication, or any other recording of any form without the express knowledge of Tech College. Now, as I mentioned previously, if you need more of these question papers and answers, we can provide you for a fraction of a price at Tech College. We'll have a full version of the memorandums that are provided by the Department of Education, as well as in video format, these question papers and answers that I'm providing, such as the one that I'm just providing right now. Now, if you need more of these, please contact us in the details that I previously showed you. Now, as I said, this question paper is a Mathematics N3 question paper, and it was written on the 10th of August in 2017. Now, for those who wrote this paper, unfortunately, there were two papers that were produced. The students wrote the first paper in July. I think it was the 24th of July. However, because of some leakages, the paper leaked. There was another question paper that was produced where students had to write again the exam, and this one was written again on the 10th of August 2017. So sometimes you'll see a question paper written 24th of July 2017. It does not mean that two papers were written in that year. However, it means that the paper was written, but unfortunately, because of some system or of some leakages that happened, it forced the Department of Education to produce another paper that was written again. We will also provide you with that 2017 July paper, given an opportunity, so that you can see how the two papers were differing. Now, this Mathematics N3, it is a 3-hour paper and the total marks is 100 marks. Now, it is very important for you to read instructions in the beginning before you start answering any part of the questions. Now, you're supposed to answer all the questions. Number 2, read all questions carefully. Number 3, number the answers according to the numbering systems used in this question paper. This is very important because you must not come up with your own numbering system. Neither should you forget to number your answers. Sometimes students, you find that they answer the question, but they forget to write the numbering system. It is very important for you to use the correct numbering system. Questions may be answered in any order, but subsections may not be separated. So what they're saying is that candidates or students are allowed to answer the question in any order. For example, you can start with question 5. Now, in question 5, you can answer the subsections, which is 5.1, 5.2.1, if those are the subsections given, 5.2.2. If the question is ending with question 5.6, you need to answer 5.6. Now, before you can move on maybe to question 3, now in question 3, you also answer all the subsections, maybe from 3.1 to 3.8. That's what they are saying. When you are starting a question, you must finish the whole part of that question so that you don't cause some confusion. Number 5, show all calculations and intermediate steps. Please don't leave out your working in your some people they can answer. I find that they write their working in the question paper, but however they don't transfer those calculations into their answer script, leading them to lose some of the marks. All graph work must be done in the answer book. There is no graph paper that is provided, so you must use a sketch, which is most accurate. All final answers must be accurately approximated to 3 decimal places. Remember, if they don't specify, you leave your answer to 3 decimal places. Diagrams are not drawn to scale, so every diagram drawn, you must not use a ruler to measure or think that it is drawn to scale. The attached formula sheet is not necessarily complete. That's something that you also must know, because some of the formulas are not given. However, it is the duty of the student to remember the formulas. And then lastly, which is very important also, is for you to write neatly and legible. So please, you'll be penalized if you write in a way that is not visible to those who are marking. Let us look at the first question. It says factorize the following as far as possible. The keyword there, yes, we are factorizing. However, it says as far as possible, and the next one says in prime factors. So what are we given? We're given 3, 1 plus 2k squared minus 8, 1 plus 2k minus 3. Now if we are to factorize, as you can see, the best thing that I'll say is to let 1 plus 2k be 2k. In this case, let 1 plus 2k be equal to your m. So that's something that we can look at so that you can simplify. It makes it easier for you to simplify if you let it be equal to m. Why? Because now where there is 1 plus 2k, you now put an m, you will have, in this case, 3m squared minus 8m minus 3. As you can see, it becomes easier for you to solve that. Now, what I usually use to solve this one, I use the product and sum method. In other ways, let me divide my line in this case. As I said, I use my product. Product means times, P stands for product, sum means plus, S stands for sum, and F stands for my factors. So what I'm looking for, my product is multiplying the first part and the last part, which is my product is minus 9m squared, and my sum is the center number here, which is minus 8m. So I'm looking for two numbers which when I multiply them I get minus 9, and when I add them I get minus 8. In other words, I'm looking for factors of 9, and factors of 9 is 1 times 9. Another factor of 9 is 3 times 3. So now the only factor that can give me, all these two can give me a product of 9. However, I need a product of a negative, but they must also give me a sum of minus 8. So definitely 3 and 3 will not give me that, except 1 and 9. Now I need, since the product is negative, it means one of the numbers will be negative. So it can be 1 or it can be 9, but my sum is the guiding factor. It says the sum must be negative, which means the bigger number has to be negative. So what I have now, my two numbers is minus, if I can make it clear there, my two numbers is 1m and minus 9m. So if I rewrite them here, I will have 3m squared plus 1m minus 9m. I'm substituting where there was 8m minus 3. Now, if you want more information on the product and sum method, you can always refer to my videos on mathematics in N3 curriculum, whereby I go deeper into this method of the product and sum with more examples that I'm giving. So the next thing that you look at now is to factorize the first two and factorize the last two. So what's common in the first two is m. So with m being common, you have got 3m plus 1. The next one is minus 3, because you must still get 3m plus 1. So now you have got m minus 3, which is outside the bracket, and 3m plus 1, which is in the brackets. Now remember, we are putting equal signs. So that's what we have. So when you factorize it, you are getting m minus 3 and 3m plus 1. But remember, this is not the final answer, because you told us that m is, or I told you that m is 1 plus 2k. I made m to become 1 plus 2k. So now, since I have m minus 3, and also I have 3m plus 1, from that, and remember we said let m was equal to 1 plus 2k. Now you have to substitute now. Therefore, this is equal to 1 plus 2k minus 3, and 3 bracket 1 plus 2k plus 1. So you have to expand the bracket in the second part. So it's collect like terms. So it's what you have there. In a way, you've got 2k plus 1 minus 3, and if you expand, the 3 will multiply like that, so you can see it expand there. So you've got 3 times 1 is 3, plus 3 times 2, it's 6k plus 1. Again, collecting like terms, you're going to have 2k minus 2, 1 minus 3 is minus 2. If you also collect like terms here, you'll have 6k, 3 plus 1 is 4. But you can see now, they said factorize, there is the keyword, as far as possible. Yes, we have done that in prime factors. You can see that 2, we can take out a 2 from the first, we can take out a 2 even from the second. So now I'll take out the first 2 from the first one, and the second 2 from the last one. The first bracket 2 is common, the second bracket 2 is common. So now what do I have? It's k minus 1, and we took out the 2 again. We've got 3k plus 2. So 2 times 2, which is 4, k minus 1, and 3k plus 2. So in this case, this becomes the final answer. So I know it looks a bit long, but for you to get your 3 marks, it was best for you to take it in a way that looks longer, but making sure that you don't make unnecessary mistakes. So then that is the final answer. Now 1.2 says, determine the smallest value of k for which the expression x cubed plus 5x squared minus k into x minus 4 is exactly divided by x minus k. That is 6 marks, which is quite a lot of marks for you to look at this question carefully so that you don't lose your marks. Now we want the smallest value of k. What we can do is let's make f of x be equal to x cubed plus 5x squared minus k x minus 4. So now they are saying determine the smallest value of k for which the expression is exactly divided by x minus k, which means x minus k is a factor. If x minus k is a factor, it means x minus k is equal to 0. Therefore, what we know is x is equal to a k, because k is a factor. Now, knowing that k is a factor, what we know is if k is a factor, f of k is equal to a what? A 0, because k is a factor. So now, if you substitute now f of k into the original, you're going to have k cubed plus 5k squared minus k minus 4. And remember, this must give us what? It must give us a 0. When you solve it, you have got k cubed plus 5k squared, and then when you expand the bracket, you have got minus k squared plus 4k is equal to 0. In this case, we can leave out that other equal sign so that we've got one equal sign. So you can say this proceeds to, an error means it proceeds to. Now, what you notice there is to collect like terms, whereby you simplify now as k cubed and then plus 4k squared plus 4k is equal to 0. Now you solve out for k, you take out k, you can see k is common in everything, so you'll have k squared plus 4k plus 4 equal to 0. And then you continue to solve it, you have got k. If you factorize using the product sum method again, what you'll have k plus 2, and you also have k plus 2 equal to 0. Now, if I can divide my page so that I can just finish it in this page. So what do you notice there? You notice two values of k. Now, therefore, k is equal to 0, or k is equal to negative 2 twice. As you can see, the first value of k is either k is 0 or k plus 2 is equal to 0. In this case, k is equal to negative 2. Now the question is, what is the smallest value of k? Now, smallest value of k is equal to negative 2, because from this 2 is either k is 0, which was the first one they gave us, or k is equal to negative 2. So that answer is negative 2, and you get how many marks? You get your 6 marks for that. It wasn't that difficult, but you needed to be careful on that. Let us look at the next question. It says simplify the following expression. Now you are given different expressions there. There is a division sign, there is a multiplication sign. So if I can rewrite it, 1.3, what are you given? You're given a squared plus a minus 6 over a squared minus 9 divided by a squared minus 3 plus 2 over a squared minus a times a minus 3 over a. Now, if you try to solve that, the whole concept of this algebraic expression is for you to remember again the product and sum method, because that's the one that you're using to factorize some of the parts, as well as also noticing a few things. Now, if you notice this one at the bottom, the denominator there, it's a difference of 2 squares. The top one is a difference of 2 squares. It's a difference of 2 squares. Here, a is common. So let's factorize it using the first one, a squared plus a minus 6. If you factorize it using the product and sum method, you'll get a plus 3 and a minus 2. Remember I said you have to refer or rephrase or revise your product sum. The denominator, a squared minus 9, is a difference of two squares, which is a minus 3 and a plus 3. Now, what you know about the division and multiplication is that when I multiply, what will happen is the denominator will go up and the numerator will go down. So that's what is going to happen here. So now you can see that the a squared minus a will go up, but a is first common, so I'll take it up while I'm factorizing, which is a minus 1 over, now the numerator is becoming the denominator again, it's factorizing using the product sum method. It's a minus 2 as well as a minus 1 times a minus 3. There is nothing common in the last fraction. Now the next thing that you need to do is for you to cancel out what you think is common. Remember, it's now everything is multiplying, so we can start cancelling out. A plus 3 can cancel with a plus 3, and a minus 2 can cancel with a minus 2, and a minus 1 can cancel with a minus 1. You can see we've got an a minus 3 cancelling with a minus 3 and a cancelling with an a. So now what you pick up there, you can see that the only thing left, everything cancelled, which means only 1 is remaining. Please, it's not 0. Sometimes people write 0 to say nothing is remaining, but it's not 0, it's 1. It means the top part is divided by the bottom part to give a 1. So the answer there is a 1. And then you get your nice 6 marks. This is a part where you must capitalize on your marks. Make sure that you don't get these expressions wrong, because it's the place where you will capitalize most of your marks. Let us move on to the next question. The question says simplify the following. Now that's question 2. It says simplify the following, which is 2.1. It says x minus 2 root x plus 1 over root x minus 1. Now looking at the marks, is 2 marks. You should have quickly gone to the final answer. Now I'm also using in a way the product and sum method, but I'm going to simplify it and try to use the K method, whereby you say let. So let's simplify it quickly. This one, in a way, what you should have seen, because it's 2 marks, should have come up with the bracket to say x minus 1 square root of x minus 1 over square root of x minus 1. Now this is what it simplifies to, and then you cancel the x minus 1, and the final answer was square root of x minus 1. But now the question is, how did this become? If you are still not confused, because you need to have done these kind of problems before, so that you can identify them. Let me try to do them in a longer way. So as I said, the previous version was x minus, if I can write it, x minus 2 root x plus 1 over root x minus 1. Now what you can say is, if I can divide that, is to say let root x be equal to your m or your k. So now when you square root x, what you have, you also have m squared. In other words, x is equal to your m squared. So if x is equal to m squared, you come to the original, which says where there is x, you put now m squared minus 2. Where there is root x, remember it's m plus 1 over root x is m minus 1. Now you can use your product sum method. This will then become, using the product and sum method, m minus 1 and m minus 1 over m minus 1. Now you can cancel out then the m minus 1. What is remaining there is m minus 1. Now remember, this is not the final answer because you told us that what is m? M is square root of x. So here then say square root of x minus 1, taking us back to the previous solution we did, whereby x was square root of x minus 1. So whatever method you could have used, it was going to give you the answer. However, 2 marks, you could have gone straight to the final answer. Let us move on to question 2.2. Question 2.2, the first part says, in 2.2.1, we are solving for x in the whole of question 2.2, but the first one says, solve for x, that is x squared minus x minus 6, by completing a square. So please don't solve it. You can solve it using the product sum, you can solve it using the quadratic formula. However, in this case, they are emphasizing you have to solve it by completing a square. So you need to complete a square in this case. So what I have given is x squared minus x minus 6 is equal to 0. You need to know how to complete a square. You can refer again to the previous lesson that I've done regarding completing a square, and you'll be able to follow up this quickly. It wasn't a difficult problem actually. So now, moving on, you can see now the best thing to do is to transpose the 6 to join 0. So we have got what? X squared minus x is equal to a 6. This is completing a square, so there are stages in that. Now we have to continue now and say x squared minus x plus half the coefficient of x. What is the coefficient of x? Is minus 1 over 2, and we square that coefficient because there is a 1 there. It's a negative sign. You can see there is a hidden 1 there. So that's the coefficient of x, which is minus 1. Then you divide that coefficient by 2, you square. But what you do on the left, you also do on the right. Minus 1 over 2 squared. When you have done that, now you look at the square. Now this is now a square, which is x minus 1 over 2. Everything in a square is equal to, now if you take your calculator, 6 plus minus 1 over 2 in a square, you'll get 25 over 4. Now what you need to do next is for you to find the square root. So if you put a square root of x minus 1 over 2 squared is equal to, again, plus or minus, that's how you do it, square root of 25 over a 4. Again, I can divide my line. Now if I continue here, now what I have is, if you can look at it, because I've removed the square by putting the square root, so I've got now x minus 1 over 2 is equal to plus or minus square root of 25 over 4 is 5 over 2. So now you've got x then is equal to, take the half to the other side, it will become positive, which is 1 over 2 plus or minus 5 over 2. So you can see now x is equal to 1 over 2 plus 5 over 2, or x is equal to 1 over 2 minus 5 over 2. Now because of my space, you can continue now to see that what will be the value of x. 1 over 2 plus 5 over 2, it will be giving you a 3, or 1 over 2 minus 5 over 2, it will give you x is equal to a negative 2. So the values of x is, we can write here on top, x is equal to a 3, or x is equal to a negative 2. Just because of space, I have to write it on top there. But this was written in form of completing a square. So Look at it carefully, how it's done. Refer to the previous sessions of completing a square or how you're completing a square. There are different ways you could have done it. Sometimes you could have completed a square even without letting the 6 first jump the equal sign, but whatever way, you're still going to get your answer. Now let us move on to the second one. Again, we're still solving for x. It says 2.2.2. It says solve for x. So what are we given? We are given 5 exponent x plus 1 over 5 exponent 1 minus x is equal to 750. And they gave us it's 5 marks for that. It's good 5 marks that you can't let go. Now, also to emphasize, before I move on to that one, whenever they give you a part to say solve for x, for example, we got our answers, in this case x is equal to 3 or x is equal to minus 2. You can prove your answers, if I can use another pen here to say proof, because proof, but this is done in your separate piece of paper. You can prove now where there is a value of x. For example, you said x is 3, you take it into the original equation. Where there is x squared, now you put a 3, so it would be like 3 squared minus x, which is minus 3 minus 6. This must give you a what? A 0. So 3 squared is what? 3 squared is 9 minus 3 minus 6 minus 9, which is a 0, to show that your answer is correct. But remember, the proof, you do it in your separate piece of paper. So every time you are getting the value of x, or you are solving for x, or whether you are solving for k, whatever, when you put it into the original, it must give you, or it must balance up, as I'm going to show you also in this one. Now, moving on, we are supposed to solve for x. We're given that. Now, one thing that we can do is to take the 1 over 5 minus x using the laws of exponents to the top. So what you have got 5 to the exponent x plus, now if we are going to take this to the top, what you'll realize is it becomes a negative. The exponent becomes a negative. So it will become 5 to the power negative, but bracket 1 minus x, because that is combined, is equal to 750. So if I open that bracket there, plus negative there, it's 5 to the power negative 1 plus x is equal to 750. Continuing, now the next thing is for me to split this 5 to the power minus 1 plus x using laws of exponents, which is 5 to the power x plus 5 to the power negative 1 dot 5 to the power x is equal to, again refer to the lesson on exponents in the previous lessons that I've done. If you have them, you'll be able to see how I did that. If you don't have, request them for a fraction of a price. We'll give you this, and it will be worth it for you so that you don't struggle. Now, what do you notice there? You notice that 5 to the power x is now common. We are factorizing it out. So 5 to the power x, take it out. What you have got 1 plus 5 to the power minus 1 is equal to 750. Now, with that, if I can rewrite it again, 5 to the power x, 1 plus 5 to the power negative 1 is equal to 750. So simple thing that you need to do, because we are using a calculator, divide by what you don't want, which is 5 to the power negative 1 over 1 plus 5 to the power negative 1. Then if you cancel that, it means, what is 5 to the power x? If you are using a calculator, punch it as it is, 750 all over 1 plus 5 to the power negative 1, you are going to get 6 to 5. Now, again, you have to express 6 to 5 in terms of exponents, in exponential form. You'll find that 5 to the exponent x is equal to 5 to the power of 4. Now, if the bases are the same, therefore it means x is equal to F4. Just trying to, for some people in this case, they'll be wanting to introduce logs. You can say, let me use, because it's a different method. At this stage of your solution, you can say log 5 exponent x is equal to log 6 to 5. You see? And then what you have here, you drop the x and say x log 5 is equal to log 6 to 5. Then you divide by log 5 on both sides. Now, if you use a calculator again, you'll get, it will give you x is equal to 4. Now, as I said, it is always important to prove your answer. Now, I'm going to use in a black way to prove our answer. What are we given? We were given 5 exponent x plus 1 over 5 to the power 1 minus x. Now, this is my proof. You are not supposed to write the proof in the answer script. This is done only in your rough work. So remember, this is my x. This must, now if I substitute it, remember my x is 4. It's 5 to the power 4 plus 1 over 5 1 minus 4. Now if I use my calculator, it gives me 750, which is equal to my right hand side. It means my answer is correct. Then 100% I know that whatever way this answer, I will get it correct. That's the best way for you to always try to work on this problem, where you can prove whenever you're solving for x. Let us move on to the next one. Number 2.2.3. It says, again, we're still solving for x from the previous question. It said solve for x. If you still remember, it was like solve for x. So we've got now 2.2.3. It says log. Now it logs, which is interesting. It's log, if I can rewrite it that, log 3 exponent x plus 3 exponent 1 minus x. They are bringing something similar again, is equal to log base 3 of 1 plus log 4 over log base 2 of 2. Now there's some things that you needed to establish first using the laws of logarithms before you can move on. Already what you know is any log base of 1, like here in log base of 3 of 1, it is always a 0. It doesn't matter if it was in base 10, as long as log 1, it gives you a 0. That you should have known. And also you must also know that log base 2 of 2 also is a 1, or log base 10 of 10, log base 5 of 5. So a base and a number, if they are matching, it is a 1. So these you should have already established them, because they are already laws of logarithms. So now what you are having now, you are having in this case log 3x plus 3 1 minus x, as you can see, that is equal to 0 plus log 4 over a 1. That's basically what that question is saying. So now, in which case you are only having log 3x plus 3 1 minus x is equal to log 4. Now again, using the laws of logarithms, you can see that it's the log in brackets. So it means if this is the log in brackets, it means then this part after the log is equal to that part. So what does it mean? It means that 3 exponent x plus 3 1 minus x is equal to a 4. That's what basically it meant. So now if you take it further, you can now try to simplify that, and trying to simplify that, you have to split again. 3 exponent x plus 3 exponent 1 dot 3 to the power negative x is equal to a 4. Now it means 3 exponent x plus 3 over 3 exponent x is equal to a 4. Let me try to divide my page because it seems there is a bit of working there. Now the next thing I have to do is to multiply, because there is a fraction there. I have to multiply by 3 exponent x. So it's like I've got 3 exponent x, which must multiply 3 exponent x plus 3 exponent x, which must multiply 3 over 3 exponent x is equal to 4 multiplied by 3 exponent x. You can see I'm distributing 3 exponent x throughout. Why? So that I can remove that fraction there. So now I will have 3 exponent x dot 3 exponent x plus 3 is equal to 4 dot 3 exponent x. That's what I'm having. Now what you can do then, you can say let, or I can let what? Let 3 exponent x be equal to, can be k or m. I usually prefer to use m, but you can use any alphabet, but it mustn't be x because you're already dealing with x. So what we have now, we have got m times m plus 3 is equal to 4m. If I rearrange it, m times m, you've got m squared minus 4m plus 3 is equal to 0. Using the product sum method, what do you have? You have got m minus 3 and m minus 1 is equal to a 0. Now if I take it back on top there, therefore m is equal to m minus 3 is 0, so m is equal to 3, or m minus 1 is 0, so m is equal to 1. So these are the values of m, but remember, I'm not looking for m, but I know that, as we previously said, let 3 to the power x equal to m. So what I have now, where there is m, I have got 3 to the power x is equal to 3. Now 3 to the power x is equal to 3. What do you notice? Is laws of exponents again. The basis is the same, but there is a 1 there, so it means x is equal to 1, or what we have got in the second one, m is 1, we have got 3 to the power x is equal to a 1. Now what you know about a 1 is that any number to the power of 0 is a 1. So in this case we have to match the exponents. It means 3 to the power x is equal to 3 to the power of 0. Therefore x is equal to a 0. So now we have got two values of x. X is equal to 1 or x is equal to 0. Now what did I say? You can actually prove the whole of this problem by substituting x on the left. Now for the purpose of your proof, you can actually put the value. In this case I put where x was 1. So what you do is you punch the left side. When you punch the left side, also punch the right side, you find that the left side and the right side will balance. It means then you are 100% correct. Moving on to the next question, 2.3. It says make x the subject of the formula. These are 3 marks. Not very difficult, but it's something that you must make sure that you don't lose marks. Subjects of formula are not that difficult. You have to just establish certain principles of this. Now, what we have here, we are given r is equal to square root of x squared plus y squared. So that is the what you are given. Now, in order to get rid of the square root, you have to square both sides. So you've got r squared is equal to square root of x squared plus y squared. What you do on the left, you do on the right. So that's how you get rid actually of the square. So square root of x of that with a square, it will cancel out the square root. In other ways, the square root and that will cancel out. Okay, just refer to the laws of exponents. You'll understand how it goes about. But that's how it cancels. So what we have here now is r squared is equal to x squared plus y squared. Now remember, what are we making? We're making x the subject of formula. So you can take the y part to join the x part. Remember, when y jumps the equal sign, the sign changes from a positive to a negative. So what you have is r squared minus y squared is equal to what? Is equal to an x squared. Now, you also need to solve for x. So what you do is to get rid of that square, in this case now you square root. So square root of x squared is equal to, usually when you square root you say plus or minus square root of r squared minus y squared. Now if I can have my ruler there. So what it means, therefore, x is equal to plus or minus square root of r squared minus y squared. But I don't know whether they would have penalized you some marks if you left out a plus or minus. They can give you the benefit of a doubt if you forget a plus or a minus. So don't hit yourself there. Now the next one, the next question says make n the subject of the formula. So what are we given? We are given x over y is equal to z to the power of n. That's a z. Usually prefer to put a center there to make sure that a z is not like a 2. So whenever you want to make n the subject of the formula and n is an exponent, the most simple way or the best way to do is always to introduce logs. That's how you solve this one. Introduce logarithms. So what we have is 3 marks is log x over y. It's not difficult, just 3 marks is equal to log z to the power n. Why were you introducing logs? You can also rewrite this in logarithm. Remember, x divided by y. You can leave it like that, nothing wrong, because we're interested in making n. But if you know well your laws of logarithms, this is same as log x minus log y is equal to, now because also using the laws of logarithm, this drops down to become n log z. That's why we're introducing logs, because that's how you can make n to drop down. Now then on both sides you have to divide by log z. On both sides you have to divide by log z. So now therefore n is equal to log x minus log y over log z. Then that's how simple you can make, in this case, n the subject of the formula. Well, also something that though it's not part of this lesson, but you can still prove these to see whether you are still maintaining your answer. For example, you can say let x be equal to, I'm just making an any number, choose any number of x, value of x, any value. In this case, let me choose maybe 5, and then let me say 15 in this case, and then y is the one I'll make it equal to a 5, and then z, maybe I make z be equal to 20. Now I want to see what I'll get for the value of n. So in the first one from the question, it was x over y is equal to z to the power n, remember. So now what is my x over y? My x over y will be 15 over 5 is equal to 20 to the power of n, right? So now my 15 over 5, in this case 3, is equal to 20 to the power of n. So now in this case you can also take your n from the answer you get. You say n is equal to log 15 minus log 5 over log 20. Now you take a calculator. If you take a calculator and you punch that value of n there, so what you'll get is, in this case, still maintain my pen, I'm taking a calculator, n is equal to, after getting the calculator, it says n is equal to 0.3667. It's got some more numbers there. Now take the whole value of n without rounding it off, come and put it in this value, say 20 to the power. That answer that you got there, you'll discover that it will give you a 3. It means that it is balancing for the value of n, therefore you are correct. So this is a way of proving, just to make sure that you didn't make a mistake. Even also with the same, you can prove it here. You can say, okay, let me see whether I made my answers correct. I want to maintain my r. What I'll do, I'll give x a value and y a value, and then I'll get the value of r. I come here again, the value of r that I got and the value of y that I got, it must still give me the previous value of x that I got. So as they keep on balancing, it means that your answer is also correct. Moving on, 2.5. It says, Peter wants to get 2 million for his house. Okay, so he's selling a house, so he wants to get 2 million. An agent charges 20% of the selling price, okay, of the selling price for selling the house for Peter. So in this case, Peter has a house, he is selling it, but he has to go to an agent, and the agent is charging some interest to sell the house on his behalf. Now the question will be, what should the selling price be? So what should the selling price of the house be? Okay, let's establish a few things here. Because that's what we want, let the selling price of the house, obvious in this case, be x. In this case, now if the selling price is x, now remember that's what we are looking for 2.5.1. Now why are we saying let the selling price be x? Because we want to establish the first question, which says what should the selling price be? We don't know, let's let it be x. So now let's start with the agent commission. What is agent's commission? Now the agent's commission, they said an agent charges 20%. So it is 20% means 20 over 100, 20% of the selling price of the house. So the selling price is x, so it's 20% of x, which gave us what? If you use the calculator, 20 over 100 is 0.2x. So first time we've identified 0.2x is the selling price. Now remember, Peter wants to get what? 2 million. Now what we established then, because Peter wants to get 2 million, now Peter's amount, in this case, what will be Peter's amount? Remember, he's selling the house through the agent. The house will be x, and this is the agent's price, so it will be x minus the agent's price, which is 0.2x. That will be Peter's amount, right? So if you say x minus 0.2x, you can use a calculator, you can still get 0.8. It's more like here, this is 0.8x. But well, if you wanted to simplify it, you need to simplify it. So now, what do you have here? Now we are looking at the agent's commission. What will be the agent's commission in this case? Now, for the commission, is equal to, remember, the house is going to be sold at 2.5 million. And Peter, how much does he want? He just wants from that 2.5 million, he wants to get 2 million. So if you separate that, you are going to get 500,000, which is good money for the agent. I mean, Peter got his 2 million, but the agent is also going to get 500,000. It's good money. Now we're moving on to the next question. Now is analytical geometry, or coordinate geometry as they call it. Now it says in figure 1, that's question 3 now. In figure 1, A, let's identify A. There is our A there, is minus 1, 0. Then we've got B, 1, 1, C, 0, 3, and D is minus 3, 4. Now are the vertices of a quadrilateral. Quad means 4. Quadrilateral. Now it says determine the gradient of CB. Okay, we've got our two lines there, CB. Now, you know, when you're finding the gradient, even if they didn't give you the formula, so it's 3.1. If they didn't give you the formula, now gradient of CB, you can use M of CB. So now what do we have? Let's look at C. What is our C again? They gave us 0, 3. What is our B or BC? You know, CB, but BC is also fine. 1, 1. It doesn't matter how you say it. So this one, I'll make it this x1, and then I'll make this y1. Don't say x1, x2. It's x1, y1 because these are coordinates. You start with x. This is x2. This is y2. So now, my formula for gradient, as I say, I'll let it become MCP. So MCP is equal to y2 minus y1 over x2 minus x1, which is equal to, you can see my y2 there, it's a 1 minus 3 over 1 minus 0, and the answer there, using a calculator, you'll get a negative 2. So, which means the gradient of CB is what? Remember, gradient is M, is equal to negative 2. Then I'm going to do 3.2 also. 3.2, if I can divide my line there. What is 3.2 saying? 3.2 says the angle of inclination of the line through the points C, 0, 3, and B11. They want the angle of inclination. So if you take this diagram, if they want the angle of inclination, it's like you produce this line. Fortunately, I'm not able to produce this line, and then the angle of inclination is that, you can see, it's more than 90 degrees. It's an obtuse angle, so they want that angle of inclination. Maybe we call it theta there. So that angle of inclination, how do you find it? It's tan theta is equal to the gradient M. So in this case, tan theta is negative 2, and then theta is equal to arctan minus 2. When you get that, you're going to find that theta, if you use a calculator, is equal to minus 63, remember they said use 3 decimal places, is 435 degrees. That's theta, but it's negative. As we're looking, this is negative but it's acute. We're looking for the obtuse angle. It must be bigger than 90. Therefore, theta is equal to 180 minus 63.435. In this case, theta is 116.565 degrees. So that's the value of theta that they wanted for you. That is the angle of inclination. Move on to 3.3, the midpoint M of AD. Now if we go back to our question there, midpoint M of AD. So there is a midpoint there that they want us, which is M of AD, the midpoint. So now I want to find that midpoint. There is a formula for midpoint. Remember, what is your A is minus 1, 0, your D is minus 3, 4. So now if you write your A value, if you still remember, A is minus 1, 0, and your D is minus 3, 4. Now again, as I did previously, this will become my x1, y1. This is my x2, y2. So now midpoint, which is M, which is by letter M, is equal to, the formula says x1 plus x2 over 2 in coordinate form, and y1 plus y2 over 2. These are coordinates. So midpoint, where do you get this? You can find this in your formula sheet. They will provide this. Refer to the formula sheet, you'll see this particular formula. So now you substitute, x1 is minus 1 plus x2 is minus 3 over 2, and then y1 it's 0 plus 4 over 2. So M is equal to, if you use your calculators directly, you don't have to stress much, is minus 2 and 2. So if you just go straight with the calculator, they'll give you marks. It's just 2 marks, as you can see. So that is the midpoint of AD. So some they say M of AD, just to indicate that this was the midpoint of AD. Moving on to the next question. Hence show that ABCD is a trapezium. Recall that a trapezium is a quadrilateral with at least one pair of opposite sides parallel. So that's, then they're saying hence show that ABCD is a trapezium. Then they are giving you a hint. This is a hint. What is the hint saying? Recall that a trapezium is a quadrilateral with at least one pair of opposite sides parallel. So the key thing here they are showing you is the parallel side. Now remember the concept of a parallel line. For parallel lines, gradient of the first line is equal to gradient of the second line. It means M1 is equal to M2. So if we can prove that one of the sides of the trapeziums are parallel, then it means it's a trapezium. Going back to the trapezium, so now this is the trapezium A, B, as I said, A, B, C, D. Now we have to prove that one of the sides is parallel. Maybe you have to prove that that side is parallel to that side, if possible. Remember, the diagrams are not drawn to scale, but you can also use an intelligent kind of a guess. You can look at it in a way so that you don't waste time and say, let me start by proving that AD is parallel to what? To CB. Also, if it doesn't work, you can prove that CD is parallel to AB, but we'll start with the first one that it looks like, so but you have to prove it. So we're going to prove that AD is parallel to CB. So we know the gradient of what? Of CB already. They told us, or we calculated it. The gradient of CB was minus 2. We can look at this. So if I can recall there, M of CB, we got negative 2. Now let's find the M of AD. Now M of AD in this case, what you have, remember, you have got your A as minus 1, 0, and you have got your D as minus 3 and 4. So now M of AD is equal to, if this is my x1, this is my y1, this is my x2, this is my y2. So I've got y2 minus y1 over x2 minus x1, which is equal to, now my y2 is 4 minus 0 over x1 is minus 3 minus a 1. Now what you get as the answer there, the M of AD, if you use a calculator you get negative 2. So now what are you seeing? Now I'm noting that, you can divide there to conclude, I'm noting that M of CB is equal to M of AD, which is equal to negative 2. That's what we got, right? Therefore, you can conclude then, therefore, it means AD, those two lines that are vertical like this, means parallel. AD, it means the line AD is parallel to the line CB. That's what it means. It means AD is parallel to the line CB. Now, what did they say? Recall that a trapezium is a quadrilateral with at least one pair of opposite sides parallel. So if you go to that diagram that we had, you can see that there is our AD and our CB, and they are opposite lines. So these are opposite lines. So the fact that they say recall that for a trapezium, the opposite lines, if one of them is parallel, it means it's a trapezium. So what we note now is that yes, AD is parallel to CB by proving those the gradient. Yes, we proved the gradient. So therefore, in that case, you can now conclude and say, therefore, A, B, C, D is a trapezium. That's what you just proved. Next one, show that ABC is equal to 90 degrees. So now, okay, again, you can, we remember our A. Please, let's just write my A. A was minus 1, 0. And still remember the B, it was 1, 1. From the diagram, A was minus 1, 0, B was 1, 1. Now, they want us to show that ABC is equal to 90 degrees. So what do they want us to show? They want us to show that ABC is equal to 90 degrees. So they want you to show that there is a 90 degrees there. So in actual fact, they want you to show that this line and that line are perpendicular. They want you to show that they meet at 90 degrees. So what you do again is the concept of gradients of perpendicular lines that you need to know. That's what they are bringing in here. So we are going to find the gradient of BC, which we know, and we're going to find the gradient of AB. So after finding the gradient of AB, while we know the gradient of BC, then we use the concept of gradient of perpendicular lines. Now, if you still remember, M of CB, you got negative 2. Now let's find the M of AB. In this case, if I do my x1, my y1, my x2, and my y2, what will you pick up there? It's y2 minus y1 over x2 minus x1. So now M of AB is equal to, there we are going to have 1 minus 0 over 1 minus 1, and then the answer that you're going to get is 1 over 2. So you are going to get a half. Maybe it's not clear there. Let me write it there. So if we are getting a half, now this is the concept of gradient of perpendicular lines for perpendicular lines. M1 times M2, that's what we are trying to show. For perpendicular lines, M1 times M2 must give you a -1. So it means M of CB times M of AB, if they are perpendicular, they must give us a -1. So what is M of CB? Is -2 times 1/2. I'm getting a -1. Therefore, if it's like that, means they are perpendicular. Therefore, AB is perpendicular. That sign means AB is perpendicular to BC, and ABC is equal to 90 degrees. That's what you have done to prove that. Moving on, 3.6, it says determine the perimeter of ABCD if DA is equal to 20 and DC is equal to 10. Leave your answer in the simplest set form where applicable. Now the next question here is the word perimeter. Now perimeter, remember, is a distance right around the shape. Now if I bring back the diagram here, now when they are talking about the perimeter of the shape, it is the distance from AB to and BC and CD and DA. So now they told us that determine, you are given that DA is square root of 20, that's the distance, that's 20 units, and CD, which is CD, is square root of 10. So what you need to find out is to find out the distance AB, and you also find distance BC or CB. After that, you just add square root of 10 plus square root of 20 plus DB plus BC. Then you will get the final answer as the perimeter. So you are just going to add square root of 10 plus square root of 20 plus distance DB plus distance BC. So you are using the distance formula, and let me write the distance formula. You can also find it from at the back in the formula side. Go and look for it. This is the distance formula. Now I've just written the distance formula as well as the coordinates of A, B, and C as given previously. Now when you are writing the first one, distance formula, remember this can be my x1, y1, this will be my x2, y2, anything there. So the distance formula for the first one is called to square root of x2 is 1 minus 0 squared plus y2 1 just a moment there. I think I mixed the numbers. I think I'm mixing the numbers. Let me correct that. If you look, my x2 is 1, my x1 is a 1, so it's 1 minus 1 squared plus my y2 is the one which is 1 minus 0 squared. So I was using the wrong value there. If you multiply that, you are going to get square root of 5, so it's 5 units. If you do the same thing, distance of BC, in this case, or CB, is equal to square root again. This you can make it your, remember it's CB. Now B is already x2, so this will be x1, your y1. So using the same formula above, x2, which is 1 minus 0, x2 is 1 minus 0 squared plus y2 1 minus 3 squared. Then you are going to get again square root of 5 units. So you have got this square root of 5 units now perimeter of what? A, B, C, D. Now you are going to have, they gave you square root of 20 plus, they also gave you square root of 10. So you are adding now the square root of 5 plus square root of 5, and then they say leave your answer in set form. The final answer there, if you use it, it will be square root of 10, just my space, it's square root of 10 plus 4 root 5. That's the answer there. If I can put it in a box that is clear there, it is square root of 10 plus 4 square root of 5 as the answer when I'm using my calculator, but you can also cross-check that. So that is the perimeter part that they wanted. Still continuing with the same question, you did a lot of marks, 18 marks, so please, you need to make sure that you grab as much as you can from this question. So it's 3.7, determine the equation of the line passing through D, in which the coordinates of D is minus 3, 4, with gradient M is equal to minus 1. Leave your answer in the gradient intercept form. Well, they are bringing in D in this case, and determine the equation of a line passing through D. This is a different D that they are bringing about. Is now D is minus 3, 4, with gradient M is equal to minus 1. Now I'm bringing back my diagram here. Actually, it's not a different D. If you remember, D there is determine the equation of the line passing through D, which is minus 3, 4. So there is a line that is passing through this D, and it has a gradient. So that's what they want us to find. Now, even if you didn't know this diagram, you still could have calculated that. Now, then they say in gradient intercept form, don't always stress the gradient intercept form is always y is equal to mx plus c. That's the gradient intercept. Why? Because gradient is m and the intercept is c. So now, what do you know? You know that d is minus 3 and 4, and you know that m is equal to minus 1, which is not difficult in this case. Now, using the formula, y minus y1 is equal to m x minus x1. So now you make this one your x1 and the other coordinate your y1, and you substitute. You have got y minus 4 is equal to m, which is minus 1, x minus 3. So y is equal to, take 4 to the other side. If 4 jumps, and you open also the bracket here, remember this will be x plus 3. What is inside here? It will be x plus 3 because it's a negative and a negative. Now there is a negative outside also multiplying that positive. So you'll have minus x minus 3. Okay, let me just not complicate things. Let me just show you so that I don't do many steps in one. So this is simple x plus 3, as we said, plus 4. Remember, we have made y to cross, 4 to cross the other side. So now we have got y is equal to minus x minus 3 plus 4. Y is equal to minus x plus 1. That is one way you could have done it, but I can also show you another way. This is the gradient intercept form, or you could have actually used the equation of a line. Sometimes I prefer it. Y is equal to mx plus c. So what do I have? I have got my d as minus 3, 4, and my m as minus 1. So now this is my y, this is my x. See, this is my y, this is my x. So what do I have? Where there is y, I put minus 3 is equal to m, which is minus 1. X is 4 plus c. So in this case I'm finding c. So minus 1 times 4 is minus 4 if it jumps. The equal sign is got minus 3 plus 4 is equal to a c. So therefore c is equal to 1. So you know that c is equal to 1. Now you're writing it as y is equal to m. M is equal to minus 1, which is minus 1x. Now plus c, which is a 1. So you see that this equation is similar to this equation. So it depends however you want to approach it, but whatever way it will give you your answer. Now we are looking at the next question, question 4. It says determine, in this case, lim h cubed plus h squared minus 6h over that. We want to determine that is limit to 2. It's not difficult. You just needed to make sure that you know a few concepts. So now you are given lim h approaches 2, and we are given h cubed plus h squared minus 6h over h squared minus 4. So what was needed there is for you to factorize. So now if I can factorize, and then I'll write everything below because of my space. Now what we have, the top one, you have got the numerator, you have got h squared plus h minus 6, and then h, using the product sum, you're going to have h plus 3, and then you're going to have is h plus 3, and then you're going to have h minus 2. That is the numerator. And then the denominator, you're also noting that h squared minus 4 is a difference of 2 squares, which is equal to h minus 2 and h plus 2. So if I write that now all together, I'm going to have lim h approaches 2, and then what do I have? I have got, before that I've got h plus 3, h minus 2 all over h minus 2, h plus 2. Please, you need to even to show this working, you need to show it so that they can understand where you got it from. So it's also acceptable just to write it like that, because you can know how to factorize in this case. So now what you cancel out here, you can now cancel out, which is h minus 2 and h minus 2. So now what you have in this case, you are saying it's lim, because of my space now, h approaches 2, you have got h plus 3 over h plus 2, right? Now because it limits to 2, then this becomes, where there is h you put a 2, which is 2 bracket 2 plus 3 all over 2 plus 2. If you use a calculator, you'll get an answer of x is equal to 5 over 2, or 2.5. Whatever way, I mean this limits to 2.5, not h, because h is 2. So this limits, when h is 2, it will limit to 2.5. Now the problem is, if you already put a 2 in the top one here, if you substitute with a 2 and you substitute the 2, it will give you an error, meaning it's undefined. Why? Because when a denominator, if you put a 2, what you're going to have at the denominator, you're going to have a 0. So it will be 4 minus 4, which is a 0, and anything divided by 0 is undefined. So what is needed there? They needed you to first factorize before you can substitute 2. So that's where they were trying to catch you there. Moving on to the next question, 4.2. It says f of x is that. This is your f of x. Now if I can write it brief so that we can simplify it there. But let me see the question. Question 1. It says determine and then the coordinates of the turning points. Now let me use the space first. We'll find the coordinates of the turning point. But now the first things I have to expand. Remember it's x squared minus 6x plus 9. So if I expand there, I'll have x cubed, x times x squared is x cubed, minus 6x squared plus 9x. They want the coordinates of the turning point. So because they want the coordinates of the turning point in a way, okay, this is my f of x. I have to differentiate. So if I'm going to differentiate, I'm going to work this question, determine the coordinates of the turning point. So I'll be working on that question, even starting it at here. So what you know, if I find f prime x already, and that is my f prime x, is equal to, using the laws of differentiation. If you haven't done this lesson, you can refer also to my previous lessons on calculus. Now it will be 3 minus 1 minus 6 2 x 2 minus 1 plus 9 1. These are rules of differentiation in this case, which is 3x squared minus 12x plus 9. But what you know, at TP, meaning turning point, f prime x, this is a very important statement that you must always remember, because I'll give you a mark for that. At TP, f prime x is equal to 0. Very important statement not to forget. At TP, f prime x equal to 0. In other words, we are going to equate that to 0. Right? So if we go to our next part now, it was 3x squared again. 3x squared, I differentiated, minus 12x plus 9, you equate it to 0. You can well divide everything by 3. I think you can see 3 is just common on everything there. So what you have got x squared minus 4x plus 3 is equal to 0. Now using the product sum, you have got x minus 3 and then x minus 1 is equal to 0. X is equal to 3 in this case, or x is equal to 1. So you have got these values of x. Now the next thing now is for you, remember, to find the y values. Remember the previous question, they said it was f of x after expanding. It was f of x is equal to x cubed minus, you can even take the original one, which is f of x is equal to x. You can take that original, x squared minus 6x plus 9. It's still fine. But now you put, now the first one is f of 3 is equal to 3 squared minus 6 3 plus 9. Be careful how you'll be punching that. Now when you do that, you'll get a value of 0. So in otherwise, this is when x is 3, y is 0. That's the first coordinate. So the first coordinates are 3, 0. Again, you do the next one, f of 1. Remember the other value is 1 is 1. 1 squared minus 6, 1 plus 9. So what do you get? You get a 4. Meaning when x is equal to 1, y is equal to 4. So those are the coordinates of the turning point that they will be marking you on. So you get 6 marks for that. It's not difficult, but these are 6 marks that you're not supposed to lose. The next one says the y-intercept. Now y-intercept is 1 mark because at the y-intercept, remember, if I can rewrite that, I still remember, it says f of x is equal to x squared minus 6x plus 9. Now, when they're saying the y-intercept, at the y-intercept, x is equal to 0. The moment x becomes 0, the whole thing here becomes 0. So now, the y-intercept here, in this case, it's f of 0 is equal to 0, 0 squared minus 6, 0 plus 9. As I said, this will automatically become a 0. So y-intercept is simply equal to 0. You could have written it straight, y-intercept is equal to 0. They are going to mark you correct. Now the next question is the x-intercepts of f. Now that's where you can do some working now. In the x-intercepts, I'm going to erase that part. So just saying y-intercept is equal to 0, you're going to get mark. Now the x-intercept is where you have to do marks now. At the x-intercept, f of x or y is equal to 0. So what you have is x squared minus 6x plus 9, the one that they gave you, you equate it to 0. So either x is equal to 0 or x squared minus 6x plus 9 is equal to 0. Now if you solve that, you have, using the product sum, you have got x minus 3. X minus 3 is equal to 0. So x is equal to 3 or x is equal to 3. You can see it's giving us the same answer. So the x-intercepts are x is equal to 0. Therefore, x is equal to 0 or x is equal to 3. Those are the x-intercepts and they give you 2 marks. In a way, there isn't much for that. They no longer give you marks now for factorizing because they assume you know how to factorize. That's why it's just 2 marks. And then, moving on to the next question, says, sketch the graph of f, show all the intercepts on the axis and the turning points where applicable. Now, if we're going to sketch that graph of f, one thing we need to know, remember when you're sketching the graph, you need to refer, they said, the x-intercepts. Those are important, number 1. Number 2, the same question that you did for the turning point. So these are the most important part, the turning point which is 3, 0, and the other turning point which is 1, 4, as well as we have to focus on the x-intercept and also the y-intercept. So if I'm to now sketch the graph of f, show all the intercepts, let me use my Cartesian plane there. This will become my y-axis, this will become my x-axis. Now if I'm sketching that graph, remember there is an important point which are the x-intercepts. The x-intercepts are 0 and 3. So I can make this point is my 0, 0. And then if I can take it a bit further, this point will be my 3, 0. I want to make it. Remember the question says show all the intercepts on the axis. So I'm trying to show all the and the turning points. So in actual fact, if I'm doing that, sometimes I don't need to put it in coordinate form, but you don't lose marks. You can literally do it like this. They won't penalize your marks. Whereby here you say 0, this one you say it is 3, because you know that is 3. Now the turning points, remember there was a 4, 1 and the turning point and a 3, 0. So this was another turning point, and the other turning point was a 4, if we can make that a 4, 4, 1, there was a turning point there. They said show the what? Show all intercepts on the axis and the turning points. Now in the turning points, you really need to put it in intercept form, which is, if you go back to the previous one, on the part it was 1, 4, so the intercept there was 1, 4, 1, 4 and 3, 0. So if you take that as 1, 4 here, as 3, 0, because it's also a turning point, that's why it's an intercept in the turning point. Now if I'm to draw that graph, you'll have a graph like this. That is how the graph will look like. So now they say sketch that graph is just 2 marks. So what they needed you to be careful of is for you to have that part, and have that part. But unfortunately it's how many marks? It's 3 marks, yes. So they won't mark you for the shape, but those are the marks. Though they mark the shape, of course, even if it's wrong, you won't get it marked. But in this case, they wanted you to show all those important points. So that was the question. Now moving on, 4.3. It says, if we look at 4.3 in this case, what does it say? Determine dy over dx using the rules of differentiation is 3 marks. So we are given y is equal to x to the power 4 minus a squared over x squared plus a. You always know that you cannot differentiate a fraction at this stage. You can differentiate a fraction, but not in the n3 level. At a higher level you can, when it's a fraction. But for you, what you need to know, the moment they give you a fraction, you need to make sure that you get rid of that fraction. There is a hint that they will always have given you. So what is the hint in this case? In this case, this is the hint. It's a difference of 2 squares on top, which is x squared minus a and x squared plus a all over x squared plus a. As you can see, that is what they wanted to first to simplify and cancel out. When you cancel out that, you have got now y is equal to x squared minus a. Now dy over dx, when you're differentiating dy over dx, you only look for the part or the area where there is an x. Where there is no x, it just becomes a 0. So you can see you've got only 1x there. So when you're differentiating, it's the 2x, 2 minus 1, which is simple 2x. You can write just 2x without making it much of a 2, 1. That 2 minus 1, you can always, you know that 2 minus 1 is a 1. So that is the answer there is 2x. Now, moving on to question number 5. Question number 5, this is the last part now, is trigonometry. And with trigonometry, it's also an area where you can get good marks. You can refer to our sessions with on trigonometry, where I provide a lot of detailed information on how to simple solve tricks. It's one area that you can actually score everything. Now let's look at this. It says use the basic trigonometric identities to prove that. So what are you proving? That cos p over 1 minus p minus cos p over 1 by sin p is equal to 2tan p. So I'm not going to rewrite this. Let me write already my left hand side. So in this case, my left hand side is cos p so that I don't mix up a bit. So this is my left hand side. So it's cos p over 1 minus sin p minus cos plus sin p, as you say, is equal to, now what I'm going to have a common denominator, and in this case, what would my common denominator? It's 1 minus sin p and 1 plus sine p. Then if I'm solving that, 1 minus sine p, I'm going to have cos p on top, multiplying 1 plus sine p, and then minus cos p multiplying 1 minus sine p. So this is simple fractions that I'm doing here. So I have to expand the top and expand the bottom. If you multiply the top, you'll see that cos p times 1, it is cos p plus cos p sine p minus cos p plus cos p sine p, because it's minus cos p times minus sine p. Again, expand the bottom. 1 times 1 is 1 minus sine p plus sine p minus sine squared p. As I was saying, what I was doing, I was just expanding. Now the next thing that I need to do is to collect like terms, but you can see some things are simple cancelling, and that is simple cancelling. So what am I left with? I'm left with cos p sine p and cos p sine p, which means there are two of them, which is 2 cos p sine p, and at the bottom I'm left with 1 minus sine squared p. So here I've got, which is equal to 2 cos p because there were two of them. As you can see, it was cos p sine p plus cos p sine p, so there are two of them. And then at the bottom I've got 1 minus sine squared p. I can divide my area here. Now what we know that, I'll use this one, cos squared x plus sine squared x is equal to a 1, remember. So which means if I say cos squared x, it is same as 1 minus sine squared x. That's 1 minus sine squared x. Now if you match that and you match it with that 1 minus sine squared p and 1 minus sine squared x, in literally it means this is cos squared x. That 1 minus sine squared p is cos squared p. So I can rewrite it as 2 cos p sine p over cos squared p. Continue now. Remember, cos p will cancel one of the cos p because they are squared, remain with 1. So what do you have there? You have got 2 sine p over cos p. Now what you also know that tan x is equal to sine x over cos x. What do you have? All these are given, referred to the formula sheet. You take it from the formula sheet, you will find it that in the formulas these are given. So now sine p over cos p, you can see there is sine p over cos p now, which is 2 tan p. Now which is your what? Which is my right hand side. Remember the question was use basic trigonometric identities to prove that. Then you can say proved, and then you get your 5 marks. Is it 5 marks? You get your 4 marks instead. Alright, moving on to the next one. It says solve for x if 3 sec x minus cos x squared 150. 3 sec x is equal to cos x squared 150, and x is between 0 and 360. Now for you to do that, what you can, let me write that, 3 sec x is equal to cosec squared 150 degrees. Now, what do you know about sec? You know that sec is 1 over cos. You can also use that from the formula side. It's sec is 1 over cos. So it's 3 bracket 1 over cos x, that's your sec, is equal to, what you know about cosec also, it's 1 over sine squared 150. I mean, they never said do not use a calculator, so you can use a calculator in that. Remember, here is x is between 0 and 360 degrees. Now, they didn't say don't use a calculator, so you can use a calculator. In this case, what you'll have is 3 over cos x is equal to, actually, if I can make it much quicker, remember this is, I think you know, this is 3 over cos x, you can see. So I can cross multiply in this case to say cos x. If I cross multiply, what do I mean when I cross multiply? The 3 on top will multiply the sine squared below, and the cos x will multiply the 1 on top. So what I have is simple cos x is equal to 3 sine squared 150. I'm just using normal algebra now. Now what you have got cos x is equal to 0. Use a calculator there, 3 sine squared. Now when you're punching sine squared 150 with your calculator, you say 3, and then you use with a calculator, you will punch 3, then put a bracket, and then say sine 150, put it, and then put a square outside, because you can't put a square inside there with a calculator. So please, if you're having a problem, the square must be on the outside. So this is what you are going to get. So now what you know, which means x is equal to arc cos 0.75. So what is x in that case? X is equal to 41.410 degrees. Remember, they say to 3 decimal places. That's your x, that's the first value of x. O theta, if I use my all students take chemistry, that's the Cartesian plane. So what does it mean? It means all means sine, cos, and tan are positive in the first quadrant. In the second quadrant, sine is positive. In the third quadrant, this is first, this is second, this is third, and this is fourth. It means in the third quadrant, tan is positive, and in the fourth quadrant, C, which is cos, is positive. Now, we have solved for cos x. We've found the first value of cos x is equal to 41.4, in which case it was here, 41.410. It's positive, but the other part where cos is positive, as you can see, it is in this quadrant. So in this quadrant, what we have got 360 minus theta. So here, what you needed to say is say, or x is equal to 360 minus 41.410. Therefore, what is your x? Therefore, x becomes 318.590. So the two values of x that they wanted from you were those ones that are given. Now, again, as I said, to understand more in depth on this particular section, you need to refer to the previous lessons that I've done in the N3. Okay. Now, the next one says, consider figure 2 below. The area of triangle FGH. There is our F, there is our G, and there is our H. That's a triangle. They have given us the area. So area here is equal to 100 square centimeters. Then angle F, there is it, is 30, and G, there is our G, is 30 centimeters. Determine H. So now, if they are giving you how many marks there, as you can see, they've given it 4 marks. Now, the trick to this question is to look at this. They gave you the area. So in this case, you can use that to say, how can I calculate the area of this triangle? Now, the area from the formula sheet, it says area is equal to half AB sine C. So in this case, if the area of the triangle is half AB sine C, here the area of this triangle will be of triangle area of triangle FGH. If you're using the formula now, it will be 1 over 2 and then small g multiplied by small h sine f. Again, you need to refer that to the formulas so that you can understand. So it's half gh sine f. So if I can write that, area is equal to 1 over 2 g, remember I said 1 over 2 gh sine f, and which is equal to 1 over 2, remember our g that they gave us in this case, g is 30 times 30 times h sine, and you see our f is 30, so sine 30. Now we have got that, but area of what? Area of FGH is 100. They gave you that 100 is equal to 100. So you've got two areas, the one involving an H and the one involving 100. Hence the question says determine H. So with that you can now solve for H, in which case you're saying 1 over 2 times 30 sine 30 is equal to 100. So 1 over 2 there is just a 15. So you are going to have, I'm leaving out an h there because there is this h. So there you are going to get a 15. So in this case now you have got 15 h sine 30 is equal to 100. So I divide by 15 sine 30. What I do on the left, you must do on the right. So when I do that, cancel that. So you've got your h. Using a calculator, you're going to have what? You're going to have h is equal to 40 over 3, which is equal to 13.333 centimeters, because they say leave your answer to 3 decimal places where applicable. So this is the part where you're supposed to leave that answer in that. Then 5.4, it says 5.4 says from the top of a lighthouse 100 meters above sea level, the angles of depression to both A and both B are 40 degrees and 25 degrees respectively. Calculate the distance between the two boats. From the top of a lighthouse 100 meters above the sea level. Now let us try to sketch this. Now let us look at this sketch. Now we are saying that is the top of a lighthouse, and then this lighthouse, it is 100 meters up. Then says from the top of a lighthouse 100 meters above the sea level. So this is the sea level. So we'll call it, this is the ground, the sea level. So let me call it G in this case. I'll call that the ground for G. It says the angle of depression. the angle of depression to both A. So the top of a lighthouse, the angle of depression to both A and both B. So both A is the 50 and both B, because they say it respectively, is the 25, so that you don't confuse that. So both A, the angle of depression to both A is 40, not 50. I'm making a mistake there. It is a 40 degrees. So the angle of depression to both A. So if I want to look at A, that angle of depression to both A, remember now the angle of depression is always horizontal. So you have your line, so now for you to see both A, you must turn your eyes from the horizontal down there. So that whole distance is going to be 40 degrees. You see that? Because it's bigger. Now, when you do that, you'll see a board here. That will be board A. And then the next one also says the angle of depression for board B. If I want to see board B, also from the same horizontal line, because it's a smaller angle, which this one is 25 degrees, I'm going to see here board B. You see that? And then it says calculate the distance between the two boards. In other words, you are looking for that distance, and then let's call that distance is what? AB. That's the distance that we're trying to find. But now, using our trigonometry, so you can see that the whole angle there is a 90 degrees between the tower and the horizontal line. So it means if it is 90 degrees, which means this part here, if the first part is 40, it means this part here is 50 degrees. That is very important. Alright? Also, this part here is 40 minus 25, which is 15 degrees. Just to write that. Maybe you might need that. This is how you understand also some of this part of the diagram. So now, you can literally come up with different, remember this one, you use now SOHCAHTOA, meaning sine is opposite of a hypotenuse, cos is adjacent of a hypotenuse, tan is opposite of adjacent. Now you have to refer again to the lesson on trig, solving these trigonometric problems. It will be easier for you to identify that. Now, the question is, we need, for us to find AB, we need to find distance GA from the ground, from the origin there, GA, and we also need to find distance GB. If we subtract GB from GA, we'll get that. You understand? We look from the distance from this part to that part. Then we look from the distance from that part to that part. Then we subtract to get AB. So now let's start with the distance GB in that case. Now if you want to start with the distance GB in that case, so what we have is we are looking at the whole triangle, and that triangle, I'm gonna make it a small sketch here. Now just gonna make a small sketch here. That's my G and that's my B. Now that's my T. Now if you still remember, we said for that whole triangle is 50 plus 15, then you have got a 65 there. You see, and here it's 100. So now what you're going to say now is 10, 65, 10 theta, using SOHCAHTOA, there is your 10. 10 is opposite over adjacent, is equal to opposite. So now which one is my opposite? If I go to my diagram again, remember that is 65. So this is my opposite, this is my adjacent. So tan 65 is opposite, which is BG, in a way, BG over my 100, right? So now, remember this is over 1. I have to cross multiply now. If I cross multiply, I'm going to have BG, in this case, is equal to 110.65. So leave it like that. You do the same thing again to find now GA. Now GA, you also come with a diagram like this. It's a diagram like this. Then this is G, this is T, now this is A. Now if you remember on the diagram what you had 50 degrees for this one. Now put the 50, it's not 65 at 50, then still you have 100 there. So you do the same thing, 10, 50 is equal to opposite. So this is your opposite because these are 90 degrees. Remember, you need to know and understand the triangle. The hypotenuse here is the longest side. So it's opposite, which is your AG over 100. Again, here you say over 1. You have to cross multiply. So we are going to have AG is equal to 100, 10, 50 degrees. This was 65, this was 50 degrees. Now, as we said, for you to find AB, you subtract BG from AG. So AB, therefore, AB is equal to BG minus AG, which is equal to 110.65 degrees minus 110.50 degrees. And what you get is the answer, which is 95.275 meters. Remember the distance that they've given us in meters. So that is the distance between the two poles. So the question is calculate the distance between the two poles. So that is, in this case, distance between poles. The poles. Now, in a way, that's why they say sometimes include diagrams and your sketches. Remember, they say that. So it's good to have this kind of sketch, but it's not necessarily that you to give you marks, but it's always good because it communicates with your working, so it will be much easier for that. Now, let us look at the next one. It says the sketch in figure 3 represents the graph of f of x is called m sine nx. Determine the following. So you can look at that graph. It's turning at 2 and minus 2 there. This is a negative 2, this is a positive 2. That's where, just to be clear, that's what they're showing there on the graph if it's not clear. But now they say determine the following. What's the first case? The values of m and n. So this is the last question. As you can see, the total is 100 marks. So the values of m and n. In this case, m is always the amplitude, the highest point of the graph, and you saw that it is at 2. So here you can simply say m is equal to a 2. Also, the next part that you need to determine is also the n part. Now, if you look carefully, you can also use a calculator to check. You will discover that if you say sine 60 or sine 30, say sine 30 must give you a half. So sine 30 is supposed to give you a 1, but in this case, sine 30 is not giving you a 1, which means this graph is not, n cannot be 1. N cannot be a 1. Now, if you try for n is equal to a 2, you'll discover at this stage, this is a 45. You expected sine 45 to have like a square root of 2. So now sine 45 is now in the place of sine 90. So it will be sine 245. Let's say n is equal to 2. So which is equal to sine, remember m in this case, m is a 2. So it will be 2 sine 245, which is 2 sine 90. And what is 2 sine 90 is a 2. In this case, you can see that it is matching. So in actual fact, what is happening here, what you are having here is you are having, remember, f of x is equal to, we know our m, it's 2 sine n, which we don't know, and then our x. But this, you know that when you simplify that, we must get a 2. I'm looking at these two coordinates. So now here you know that in this case our x there is 45. So you've got 2 sine n 45 is equal to a 2. You divide there by a 2, divide by a 2, you are going to have sine 45n is equal to a 1. So now for you to get when is it that sine is equal to 1, sine is equal to 1 when n is equal to 90. So you do that, you have got 45n is equal to arcsine 1. I'm trying to show you how you can work this out, but it doesn't mean that you need it to work out. So what is arcsine 1? So which is equal to 90. So you divide by 45 on both sides, divide by 45, you can see that n was equal to 2. So you didn't need to work it out, but in this case, it just says the values of m and n determine n was equal to a 2. Again, maybe just to say, you might not have understood. Again, let me write this. 2 sine, for the purpose of your working, for this n is equal to 2, it's 2 sine n dot 45. You say it is equal to 2. I just took these two coordinates. When there is a 2 between 30 and 60, there is a 45. So now here you divide by 2 here. So what you have is sine n times 45 is equal to 1. How do you find this angle? Say n times 45 is equal to arcsine 1, which is 45n is equal to, if you look at arcsine 1 in a calculator, it will give you a 90. So you divide by 45 both sides, then you're going to get your n is equal to a 2. That's why you said just n was equal to 2. So the answers though is for you to say, to get your 2 marks. N is equal to 2, n is equal to 2, they would have given you marks. Then the next one says the coordinates of R and Q, the maximum point and minimum point of F respectively. Now let's look at the coordinates of R. Now this part here, if you can see, we actually have done it. R, you start by X, which is 45, and then followed by Y, which is a 2. So here you can now write R as 45 and 2. Now what about the coordinates of Q? Again, the coordinates of Q come here, because we are looking at between, just similar, between 30 you added a 15, 30 and 60, the 15 gave you a what? The 15 gave you a 30 plus 15, it gave you 45. Again here at the center here, we have to add 120 plus 15, it will give you 135 here. 135 is your value of X, and your Y is negative 2 because it's now below. So now your R is 135 and it's negative 2. So that is the two answers that they were needed there. So it was a matter of using your graph to interpret or to get those values of X. Now we have come to the end of this particular lesson. As I've indicated before, to say we have got a whole curriculum of mathematics in N3 that you can use for your preparation for your final exams. So if you are attending class, it is always good to try and have alternative methods or different approaches to your math so that you can enrich your math. And should they give something in an exam that should have tricked you, maybe through exposure to different ways of working, you will be able now to see how the questions were trying to trick you and be able now to find or to solve or get your answers correctly. This is through practice. The more you practice, the more you get lucky, as they always say. The more you practice, the more you'll get lucky. Meaning, the more you practice, the more you'll perfect your skills. Now, we have come to the end of our lesson. You can always email us on the information shown, or you can you can call us on 011-040-7343. My name is Confident. See you again in the other chapters, or see you again in other question papers and suggested solutions. Thank you.